We're going to continue our discussion about geometry. In particular, we're going to be talking about triangles. Strangely enough, we're going to talk about other shapes before we get there. But I think by talking about those, it'll help you understand some of the concepts of the triangle a lot better. So let's jump in. So here's a question from Brad. We're planning on pouring concrete in a wall form that is sloped. One end is 73 inches tall, and it tapers to 24 inches tall over a distance of 348 inches. It's flat on the bottom and the sides, and is 12 inches thick. Thank you. So basically what Brad's asking is, how many cubic feet of concrete am I going to need? Now you probably remember that to figure out cubic feet, you need the height, the width, and the depth. But how do we do that when we've got a sloped area? Well, I think the best place to get started is by looking at the square, strangely enough. Now, as you can see, I have a square, and I've dimensioned the sides. They're 4 units apiece, and we could easily find the area by taking 4 times 4 and coming up with 16. Now, this method of height times width will work for rectangles, and it'll work for squares. However, it doesn't work for all shapes. So something with 4 sides is called a quadrilateral, but we can change this quadrilateral a little bit so that it's no longer square. For instance, if I grab this top part and I begin to bring it down, you'll notice that the units, the measurements for the sides are still the same. However, the more I bring that down, the smaller the area is on the inside. So a square and a rectangle are a particular type of quadrilateral in that their angles are 90 degrees. When we begin to change those angles so they're no longer at 90, we have to begin to calculate these a slightly different way. And that looks something like this. So you can see I've added a ray to our drawing. And now let's set up the height or the altitude from this point to our ray. So now you can see that our height equals 2.57 and some change here. As I begin to increase this, we eventually get back to our 3.999. So to compute the area of our parallelogram here, and you'll notice both sides are parallel to each other, what we actually would do now is use the base, or in our case we're going to pick the bottom, and the height. So we have decreased the area from 16 down to 4, that's the base, times the height, which is 2. So the area is now only at about 8. And we could go even more, someplace close to 1. And just by changing the angles, we have now decreased the area down to 4. You can see we've got a base of 4 and a height of approximately 1. So let's move our discussion back to triangles a little bit. A triangle can be formed simply by going to the corners of our quadrilateral. Now you'll notice that as I move this, our triangle changes as well. And though you probably already know this, a triangle is a three-sided object, where our quadrilateral was 4. And we can change the area of our triangle. As you can see now, it's fairly small, and as we get bigger, there's more area, by using basically the same formula we use for a quadrilateral. We can take 4, our base, times the height, which in our case is 4 here, or 3.9999. And it's only half the quadrilateral, so we have to divide by half. So 4 times 4 would be 16. Divide that in half, we would get 8. So we can find the area of a triangle by knowing the base and the height of the triangle and simply dividing by 2. Or if you want to, you can multiply by 0.5. It's the same thing. So my recommendation is anytime you can find the base and the height, that's what you use to solve the area of a triangle. There is another way, and it's a little more complicated. We'll talk about that. It's something called Hero's formula. And you will notice that this line right here, it's called the hypotenuse. So it's the longest side of the triangle. But you will notice that as we change our angles, that hypotenuse is going to change. So you see that hypotenuse getting longer. Now the other sides are still saying the same. They're still 4 and 4, but this hypotenuse, the area from here to here, is getting longer or shorter. All right, so you already know that to find the area of a triangle, we can take the base times the height or the altitude and divide that by 2. Our base here is 4, so we go 4. Our height or altitude here is also 4. It's approximately 4. We got 3.999, so we're going to go with 4. So 4 times 4. And we're going to divide that by 2. That's going to give us 16 divided by 2. Or our area is 8. But there is another way to solve for area. And like I said, I recommend that whenever you can use the base and the height method, that's what you use. But the other one is called Hero's equation. And Hero's equation looks something like this. If we have sides A, B, and C of our triangle, we can take the square root of S times S minus A times S minus B times S minus C to come up with the area. Now, S there's Hero's equation. S in this equation is going to equal A plus B plus C divided by 2. So let's give that a shot. We've got A, B, and C. So we're going to have 4 plus 4 plus, I'll call this 5.6. Now we may come up a little bit off when we get the end because I rounded, but we'll use what we've got. And all of that divided by 2. So 4 plus 2 is 8, plus 5 more is 13. So we've got 13.6 divided by 2. And that's going to give us S. So 13.6 divided by 2. It's going to be 6.8. So S equals 6.8. Now we need to take, go back to our equation, and we've got 6.8 times 6.8 minus A, which is 4, times 6.8 minus B, which is also 4, times 6.8 minus C, which is, we said was 5.6. And we're going to end up taking the square root of that entire thing. So let's break these down. 6.8 minus 4 is going to be 2.8. 6.8 minus 4 is 2.8. And 6.8 minus 5.6 is going to give us 1.2. So we're basically going to have 6.8 times 2.8 times 2.8 times 1.2. And then we're going to take the square root. So let's do that. We're going to take 6.8 times 2.8 times 2.8 times 1.2. That gives us 63.97. I'll go ahead and stick the 4 on there. And the square root of that is 7.998, or rounds up to 8. So there are the two methods. We have Hero's formula, and we also have our base times height divided by 2. And both of those will get you area. So I drew some lines here, and I formed two separate triangles. So we've got a triangle here, and we've got one down here. Now these are similar triangles because they have the same angles, but they aren't the same size. And I can show you the angles here. Let's pick a couple. So you'll notice that both of these angles are 57.45. That angle is 59. So we got 59.17. And of course, whatever this angle is, then will have to be the same because the totals have to add up to 180. So we have two triangles, the same angles but different sides, different sizes, sorry, and we call those similar. Now if they were exactly the same, we'd call them congruent, but they are similar triangles. And what we can do when we have similar triangles is that if we know the sides of one, we can come up with the sides of the other, or the missing side of the other one, because the ratios will always be the same. I'll add in the length of the sides and I can show you what I mean. So hold on just a second. All right, we've got it all labeled here. Hopefully you can see these. I realize they are a little messy. I'll clean up a couple of things here. All right, I've got the base of this triangle and the base of this one. And then I've got our sides. Looks like I accidentally deleted one of our sides. Let me fix it real quick. There we go. And we've got our sides listed as well. All right, so let's play around a little bit with this. So what we're going to find is the ratio of this side to this side is going to be the same as the ratio of this side to this side. So the ratio of G and E to F and H is going to be the same ratio as G to I as I to H. All right, let's label these to make this a little bit easier. We'll call this side A. We'll call this side B, and this side C. Of course, there is the dimension for side D, or for side C. We'll call this side D, E, and F. And again, there's the dimension for size F. So what I was saying before is when you have two triangles that are similar, if we know side A and we know side D, so we can find the ratio there, we can also find, or that has to be the same ratio as B to E. And we can prove that. We'll say that side A is 4.4 and side D is 7.9. And that has to equal, we'll say 4.2, I rounded, and 7.5. So I rounded pretty heavily. These may not come out perfectly because of that, but let's see what happens. So I'm going to take 4.4 divided by 7.9, and I get 0.556. We can round that to 0.56. So 0.56, and 4.2 divided by 7.5 equals, 0.56. 0.56. So we can manipulate our formula to find a missing side of the other triangle. So if we know, for instance, A and D, and we know side B, we can calculate the size E. And we can manipulate our formula fairly easy to be able to do something like that, depending on which side we wanted to find. So a couple other things we'll talk about here real quickly. So we have our basic triangle here. Occasionally you hear us talk about interior and exterior angles. So any of the angles on the inside are going to be the interior angles. So this angle here, this angle here. These are all interior angles. And no matter what shape we have, any of the angles on the inside are interior angles. So when you hear us talk about interior and exterior angles, you'll know what we're talking about. Interior are the ones inside the shape. So let's hit one other topic here, which you probably already know. It's called Pythagorean Theorem. And basically it looks something like this. Let's draw our little triangle. And we'll label this side as A, and we'll label this side as B. And here is C. So Pythagorean's theorem basically says A squared plus B squared equals C squared. Now this C, this long piece here, is called the hypotenuse. And so the shorter sides, if we square them and add them together, will end up equaling the length of the hypotenuse squared. We oftentimes shorten that to say that C equals the square root of A squared plus B squared. And that gives us the actual size of C, not C squared, which is usually what we're really after. And you can manipulate this formula around too to find, if you know C and B, you can find A. Anyway, here is the hypotenuse. It's this side here. So let's talk about some things we know and solve some problems, and then we'll finally get back to our concrete example. So if this angle is 90 and this angle is 45, what does this angle have to be? Well, we know that the total angles of a triangle have to come up to 180. So we would have 180 minus 90 plus 45. 90 plus 45 is going to be 135. And 180 minus 135 is going to equal 45. Well, what if we wanted to find the area of this triangle? If we're going to find the area, what do we need to know? Well, we need to know the height. It's going to be h, and the base, right? So if we said our height was 2 and the base of this triangle was 4, we would multiply them, 2 times 4, and we would divide them by 2. So 2 times 4 equals 8 divided by 2. 8 divided by 2 equals 4. So the area of this triangle, if the base were 4 and the height were 2, would be 4. Now remember, we can also calculate the area of our triangle if we know the third side and we don't necessarily know the height. Well, why would we not know the height? Well, on this one, with a right angle, you automatically know. But if our triangle looked a little bit more like this, where we don't have a 90-degree angle, you might not know what the actual height from here to here is. And so we'd have to use Hero's formula. Actually, I think they call it Hero's equation. Anyway, so we could use that to solve for that problem. We can also find the hypotenuse, or the length of this side, since we said that A was 2 and B was 4. We could say that C is going to equal the square root of 2 squared plus 4 squared. 2 squared is 4. 4 squared is 16. So we need the square root of 20. And if we pop up the handy dandy calculator, I'll put 20 square root. And so side C is going to be 4.47. Of course, we would probably round that to some value. All right, let's come back to our example here. and figure out how we want to solve for that. Here would be the way I would approach it. So we know we come up 24 inches here. I would calculate the cubic feet in this rectangle here, right? Or cubic inches. So we know we have 348, our length, times a height of 24, times a width of 12. And then I would take this triangle and I would calculate that. So what do we know? We know we've got a side that is 73 minus 24. So that's going to be this side. We know we've got a side that is 348. So I'll just call this side A. And B is going to equal 348. Since this is a 90-degree angle, we can use this as our height. So we can say that A times B divided by 2 is going to give us the area here. And we can multiply that times our 12. So let's see how we come out. So let's do the bottom portion first. I'm going to take 348 times 24 times 12. That's going to give me 100,224 cubic inches of concrete. Now let's take a look at our equation here. We've got 73 minus 24. And remember, we had 73 inches total, but we already calculated the bottom 24 inches. So I've got 49 times our base, which is 348, which gives us 17,052. Now I need to divide that in half. Remember, this is a triangle. Get 8,526. We got to multiply that times the width, and there's 12, and that gives us, let's see, 102,000. 312, or 102,312. Add those two together. Plus 100,224. And we get 202,536. Now this gives us cubic inches. If we wanted to calculate cubic feet, we are going to have to divide by 12. But we can't just divide by 12 one time. We have to divide by 12 for each one of the dimensions, the length, the width, and the height. So let's do that. So we're going to divide that by 12, divide by 12, and divide by 12. And we get 117.21 maybe? 117.21 cubic feet, or it might look like feet cubed. 117.21. All right, there you have it. We had to use our triangle geometry to find the area of this part of our concrete, and then we multiplied it again by 12 to get the cubic inches. As always, if you have questions, please get a hold of me, and have a great day.